Okay, today we're going to talk about writing an equation. So given a word problem or given a situation, can we write an equation from that? So we want to try to start thinking in terms of slope and y-intercept and things like that. Now, we have in number one, you're at a water park and want to rent an inner tube. You have to pay a $5 fee plus $2 per hour that you rent this tube. So when we have a $5 fee, a lot of times that is our starting point. So we want to try to write an equation in two variables. So we're going to say y equals. Now a starting point is $5. I'm going to pay that $5 no matter what. If I show up to the gate and I pay the $5 and then I turn around to go get my inner tube and scrape my knee and cry and want to go home, and I turn back and give the inner tube back, even though I had, for 30 seconds, they go, oh, I'm sorry, sir, I already ran it in the system, so I can't give you your $5 back. But you don't have to pay the $2 per hour since you didn't have it for an hour. I would still pay $5 no matter what, okay? So that is just gone. See ya. But I'm going to pay plus, in addition to this $5, I'm going to pay $2 per hour. Anytime we see that per hour, per day, per year, you're going to think that there's going to be a variable attached to it. So y equals 5, my flat fee, plus this $2 per hour. Now later we're going to talk about slope-intercept form and actually how these would be flipped. But writing it like this in order that we see it is okay for right now. Now, how much would you have to pay after renting the tube for 6 hours? So let's see if this even makes sense. A lot of you are like, hold on, 6 hours? I could do this in my head. And yeah, you probably could. You probably don't need a formula for this. But we're trying to build those skills so that we can use the formula for harder problems. So let's see if our equation that we came up with is even right. So if I want to see how much I would pay after renting the tube for 6 hours, because this is per hour, $2 per hour, let's see what we get. So we would have y equals 5 plus 2 times this 6 hours. Remember, order of operations. And so we're going to deal with parentheses first. We have parentheses, but nothing to simplify. We don't have any exponents, but we do have multiplication. So let's deal with the multiplication first. 2 times 6. 2 times 6 is 12. So y equals 5 plus 12. Now we can go ahead and go through and deal with the addition. So 5 plus 12. So we get y equals 17. So let's see if that makes sense. Would we pay $17 after 6 hours? Yes, because $2 per hour for 6 hours is $12, and I pay that $5 fee no matter what. So that would be $17. Now, what about this other example? You enter a candy shop, and you have to pay $10 just to get into the door, but man, once you're in there, you only have to pay 5 cents for every piece of candy that you buy. So one thing I want you to do is be careful here, because 5 cents, when I write that as a decimal or fraction, I have to be really careful with how to write 5 cents. So writing this equation, I pay $10 just to get into the door. So it's not $10 per hour or per piece of candy, it's just $10. So y equals this 10 that I just pay as my flat fee. That's kind of my starting point. Later we're going to learn that's our y-intercept. But then afterward, I only have to pay 5 cents. So if you want to write that as a decimal, we're going to say plus 5 cents for every piece of candy. So x in this case is going to represent the number of pieces of candy that I'm going to buy. And this 5 cents, remember 5 cents is 0.05. If we wrote 0.5, that would be 50 cents technically. So 0.05. Now, this next part, let's see if we did this right. The good thing about having a way to check your work is if you accidentally were doing this on your own and wrote 0.5, you would see if you bought 100 pieces of candy, you're like, what? I just paid 60 bucks for 100 pieces of candy? And you'd be able to think like, okay, that doesn't sound right. I wonder if I messed something up. And then so you can kind of look back at your equation. Oh, yes, a nickel or 5 cents is 0.05, not 0.5. So letter B, we're going to replace our variable, x, for the number of pieces of candy with 100. So y equals 10 plus this 0.05, a nickel per piece of candy. And instead of x, it's going to be 100. So what is, again, following order of operations, 0.05 times 100, or a nickel per 100 pieces? One way you could think about it is because the 100, you're going to move that decimal to the right 2 spots. And so when I multiply by 100, I'm going to get 5. So y equals 10 plus 5. So, if they were a nickel each, and I bought 100 pieces of candy, that would be $5 just for those pieces of candy. But remember, I had that $10 getting into the door. So 10 plus 5, I would spend $15. So in a situation like this, the more you buy, the better it's going to be. Where if I walked in and I paid $10 and I only bought one piece of candy, I'm going to pay $10.05 for that one piece of candy. That wouldn't be worth it. But if I buy a lot of candy, 100 pieces of candy, I'm only paying $15 because it's so inexpensive for every piece of candy that you buy. And a lot of places do that to incentivize you to buy more, right? So they make more money. So this is how we write equations given word problems. Oh, and they're wearing their mask, and they're sharing masks. I don't think that's really what you're supposed to do. You're probably not supposed to share masks, but caring is sharing.